All right, so it's a square root graph, which means your parent is this. For those of you who haven't seen the video, okay? Now, we're going to put a couple count values here. What's the square root of 0? 0. Square root of 1 is 1. 4. I'm picking perfect squares because you input. Right? What's the square root of 4? 2. What's the square root of 9? 3. Those are your values. This is still the same transformation. So write 3 down 2. It's the HK, the vertex, except this is not a vertex because it's a square root function. It's just the starting point. From the starting point, you count your values. Over 1, up 1. That's why it says change in x. It's the change in x from the starting point. Over 4. 2, 3, 4, up 2. Why up 2? Because 2 is the square root of 4. Over 9, that doesn't fit, so I connect. There's only one arrow on this graph. The domain of this graph, hard bracket 3 to positive infinity, range, hard bracket, -2 to positive infinity. Notice that it connects to the transformation. Okay, I feel like we need to do another square root. Y equals negative square root x plus 1 plus 4. Okay, graph. It's the same kind of count values, but this time you got a negative. So what does that negative do for transformations? Reflect. Not valid. Change in y, right? All of those stretches affect the change in y. Change in y. Change in y. The negative is a reflection of the next
because like the negative before the square root, but the point it was here, but since there's a negative, that was reflected over the
now the negative, so instead of doing this shape, the negative reflects the standpoint.
No.
So the changes are going to be over 1, negative 1, over 4, negative 2. So it's going to kind of like open down. The negative.
I don't know. I didn't watch the video of that. No, you're stupid. No, I'm not stupid.
Look at that. Oh, you guys are reflecting the wrong way. Your y values are reflecting. Your y values reflect. Okay, here we go. Now, with the negative, right, this is a reflect over x. Reflect over x. Left 1, up 4. Okay, left 1, up 4. Okay, same count. So I'm just going to jot them over here. 0, 0, 1, 1, 4, 2. Except that I've got a times -1. 0, -1, -2. I'm going to scratch out that. Those are my count values that take in the reflection into account. All right, so over 1, down 1. It's reflect over x. It's opening up, opening down, except this is kind of looks like it's opening sideways. Over 4, down 2. 5, 6, 7, 8, 9, down 3. Okay. We're going to change the parent function. We'll come back and do some more radicals, but okay. Cube root. Cube root. Okay. The parent function for a cube root is this. Change in x, change in y, 0, 0, 1, 1. What's the perfect cube? 2 and 8. Okay, 8's the perfect cube. 8 is the perfect cube. When you cube root it, you get 2. It's important that you plot at least 3 points because the only difference is in the third point. If you don't give me 3 points, I can't tell what graph you're graphing. Now, keep in mind, do you have problems with negatives on cubes?
Yeah.
It's a cube root of -1, -1.
Yeah.
It's a cube root of -8, -2. Yeah, can I square root a negative? No. Okay, so there are no negatives in this table up here, but there are negatives in this table. So you've got left 1, up 2. Give me your best attempt at what do you think those count values are going to do to your graph.
Include the not because cube roots negatives stay negative. Yes.
This isn't ordered. It works easy.
Okay. So do the count values 1, 1, 8, 2. But then do the other direction.
There we go.
Okay. So you're gonna go yes. 1, 1, 8, 2. But then you're gonna go this way also. Because cube roots, negatives aren't a problem, so we have to go both directions from that center. Good.
Sure.
Just make sure I see that last dot. Good. Yep.
Everyone else is that.
Okay. Yes. Good.
Okay. Nice. So we got left 1, up 2. Here come the counts. 1, 1, 2, 4, 6, 8, 2. But cube roots, this is the big difference between the square root and the cube root. The cube root's 8, 2. Perfect cubes. But negatives, they exist for cube roots. So you're going to go left 1, down 1, 2, 4, 6, 8, down 2. And then you connect. All right, here's a little hint. Look at these 3 dots in the middle. What kind of slope do you see? I see a 1 slope. Look at your A value. It was a 1. It helps you pick out the A value, which most of the time you can do graphically, right? And positive. It looks like a positive slope. Yeah.
So if the starting point is -1, 2, where do you get the 0, 3 from?
What 0, 3?
The one that's going the y-intercept.
From this point right here, over 1, up 1.
Oh, okay.
Right? This is the start. Then you count the transformations. Now, I don't usually write the negatives in my table because I just know cube roots go both directions. All right, so let's do this. Let's do negative -3 cube root. Notice my root is tucked inside that divot. We'll just go x plus 2. Okay. Try it.
So then I'll trash that. That's okay. Right.
So this is going to be a reflect over x, stretch by 3, and up 2. Right? Go left to right in those transformations.
To make sure we got the transformation. Okay, where's your first point going to be? To the right of this.
Wait, I already got one. Sound like you talked
Go left one dot, right there, over one, up. Well, actually, not up, it would be down, because of the negative. Yes.
No, you don't. Wait, so are you making?
Yes. Yes. Up to 0, 2, start. Now, because of that -3, my first point, which is 1 back, it's really going to be times 1 by -3. So it's going to be 1 -3 from the start.
I just didn't even read the problem.
There's like 5 conventions.
Yes, yes, yes. Okay. Yes. Wait. Up 2 on the y-axis, but your shape is right. You just got to put that center in the other place.
Okay, so we have my center is right here. Now, I'll jot my table down. Okay, 0, 0, plus or minus 1, plus or minus 1, plus or minus 2, plus or minus 8, 2. Okay, and times 3. 3, 3. Okay, over 1. Instead of going up, it's got to go down. Over 2, 4, 6, 8 times 3 is 6. 2, 4, 6. Connect. And then the other direction as well. 2, 4, 6, 8. It's supposed to be up 2, but it's going to be times 3, so that's 6. When you graph these, guys, I got to see all of the points. If all you do is show me the first point, that's not enough. I can't tell which graph you're using. I have to see the 8, 2. Okay. Here we go. Let's do that one. See if you can do it without any assistance this time. We're back to square root. Back to a square root. Okay, back to a square root. What's your table of values?
Okay. Yes, you see that arrow? Just leave it flat looking. Don't tilt it back up. But that's fine. Yeah.
Oh, this is a square root. Okay, this is hard.
Square roots don't have negative. Yeah, the marker, that's fine. Here's one. Yes. Alright, I'll put one on your desk. See if that works.
That's not the trash can.
Stretch 2, left 2, down 4. Okay, the starting point, not the center, the starting point. Left 2, down 4. Okay, and let me write my counts to make sure I get them right. 0, 0, 1, 1, 4, 2. Square roots, guys, you got to shift back to square roots. No negatives. No negatives in the square root graph. Okay, times 2. So 2, 4, 6. Okay, 1, 2, 2, 4, 4, 5, 6, 7, 8, 9, 6. 2, 4, 6. The domain, hard bracket -2 to positive infinity. Range, hard bracket -4 to positive infinity. Okay. We're going to up the difficulty slightly. You're going to put 2 graphs on 1 grid. So hard. You can do it. Ready? Okay. Here we go. Find the intersection. So the way you do that is we're going to consider the left side to be y1, right? Graph the left side as is. Graph the right side as is. Right? 2 separate functions. Just graph them on the same grid. Would you hate me if I put a plus here? Put a plus there. Okay, so reshift it. Otherwise, they don't intersect in a nice place. Okay? So put a plus there and try it. Oh my goodness. Wow, put a plus here too. Sorry, it's good practice on transformations. Take your shape and shift it to the right place. I'm looking for better markers.
Use your brain.
What was the other place where you put
Just plus 4.
Wait, we're playing Uno?
Don't get rid of the eraser, but try that.
No, is it one you want to play the +4, but...
I hope they intersect in a nice place.
Me too. Otherwise,
Then we should be good this time.
1, 2, 4.
Okay, x equals. There's only one variable up here. The answer is x equals wherever they cross.
Wait, that's a square root.
Yeah, cube root, square root.
You can't just do that.
Yeah, I'm looking.
You just can't do that. You just can't. You can't do it to him just twice. You like. You really gotta do it.
Yeah.
No, you just can't do it.
I'll do it in 2 different colors. Yeah.
It's supposed to be a four. No, did I mess it up again?
Zengi.
Just leave it, but we'll talk about it.
Apparently. Ha ha ha. I just looked at my answer key. Yeah. All right, here we go. Well, let's try it. Okay, so left 2. Okay, left 2. And then cubes. Okay, 0, 0, 1, 1. Cubes. 8, 2. There's like only one number that's changing. Okay, and then pluses and minuses. So, first point,
It's supposed to be like the X.
2, 4, 6, 8. Okay, other direction. 2, 4, 6, 8, just barely off the graph. Okay, check out your middle 3 dots, guys. Your middle 3 dots look like the A value, -2. Okay, so then we'll do this one in blue. 1, 2, 3, 4. 1, 2, 3. Apparently I can't count, so this doesn't intersect in a integer point. So over 1, up 1/2. Okay, so this would be 1/2 and 1. So over 2, 4, up 1. And so you're like, I don't know, approximately -1-ish. It's not actually -1. If I have you do this graphically, I would get them to cross at an integer place. Okay? Let's do one more, and this time I'll make it work. Solve. Okay, cube root. Oh, 3 x plus 2. Okay, that's a good one. Equals 3x plus, oh, fancy. Okay. There you go. Ooh. Cube root, linear, right? That's a line. Everything you've graphed up until this point is fair game. Lines, absolute values, parabolas, mx plus b, so you can do a line. We will review parabolas again, but we'll go vertex form. We'll keep it in vertex form, transformations. Notice the directions say solve. Solving is the same thing as finding intersections on a graph. Right? Same directions. Or different directions, same work.
You would try to undo it. But graphically is a good way to
Wait,
like
wait, yeah,
check
though.
the approximation.
It did.
No, it's cube root. I mean, big oopsie.
No, look. This is the same thing. No, it is. And then you divide by 3. No, and then
Yes. Good. So where are the x coordinates where they intersect? X coordinate. X coordinate. Yes.
1.
Yeah. Just that. Nope, not 2.
Oh, wait, never mind. No.
Yep.
Just -1, 0.
I have no idea what's happening.
3.
I'm so disappointed. Oh my god, I told you. Ruined the whole.
Okay. Stretch by 3 and up 2. Okay, so up 2. This is going to be 3. 2, 4, 6, 8. Instead of 2, it's times 3, so it's 6. So it's way up here. Okay, that's fine. Other direction also. 2, 4, 6, 8. Notice I'm counting from the center, right? I'll mark it extra big. So 2, 4, 6. Okay. And linear. Oh, mx plus b. So I start here and I do a 3 slope. Okay, look for the points that you counted. Those 3 center dots actually overlap. -1, 0, and 1. Solutions are anywhere that the graphs intersect. Notice that it was x equals. Answer is x equals. There's only x's here. Okay. Different question.
Wait, oh yeah, I knew that.
Write the equation of this graph.
So bad. 1, 0, and -1. No, I'm right. 1, 0, -1.
Okay.
Stop. See this one.
Oh, I got you. Here you go. All right, there you go. That way you can see the points. Write the equation of this graph. Pick your parent. Right? Okay. Pick your parent. Fill in those transformations.
No, I know. Yeah, you do. You have a more.
Oh, it's no, I know what it is. It's wait, no, but it's like negative. It's like 3 square root of negative x.
Is that plus?
I should do it is negative. There's a +2 there. I forgot. Oh my god, you're actually like.
I think I just got it.
Wait a minute. Thanks, man. Wait, I think I
got it. 1, 3,
Check your. This is okay. Check your other transformations from the order. Yes, that's good. Okay, so square root, that's your parent. My shift, I'm going to put A. X left 4, up 4. Now let's say you're like, I don't know what my A is. Pick any other point and plug it in. Now I'm going to plug in this one because I like 0. Okay, so -2 equals A. Root 4 plus 4. Subtract square root -3 equals A. You can solve for A. You can also look at the graph and compare the count values. And they're supposed to be what? Well, it was over 1 and it was really -3. And it was over 4, -6. All right, well, what do you times by to get there? You times by A. So 1 times A equals -3. A is -3. Doesn't matter how you set it up, but you can plug in points or you can compare the ratios. But this is your equation. So y equals -3 square root x plus 4 plus 4. Domain, hard bracket on the starting point. Ooh, negative infinity comes first. It's always bottom, like negatives to positives in order. And so if you have negative infinity as part of your range, that value goes first.